Okay, this is the Capstone project for human factors and AI. And my project is a machine learning product for improving dream recall. So, the topic is that system that I just described, some type of machine learning application that functions as an alarm clock, which determines when to wake you up, such that you'll be most likely to remember your dream and then record your dream. So, kind of like a smart alarm clock dream journal. In pulling from the last course, the problem here is that people struggle to remember their dreams when they wake up, and that there's benefit to understanding yourself better when you uh, learn to improve your dream recall. So, looking at the way that people solve this today, just the practice of dream journaling is a way to strengthen your ability to recall. But there's also other techniques such as mnemonic induction of lucid dreaming, which is about setting intention before going to sleep to remember your dreams. And then there are supplements that are supposed to help with dream vividness and recall, galantamine probably being the best among them. And ultimately, when thinking through how this system might work, we would want, uh, you know, their ability to recall their dream um, to be analyzed after attempting these methods, right? So this is the kind of the schema for analyzing these tasks for remembering and improving the memory of dreams. And so the insights that came from here is that there's this opportunity to automate the process of setting an intention before sleep, providing prompts for journaling upon waking, or prompting users to record their dosage of galantamine and the experiences that correspond to each dose. Um, and, you know, ultimately, when I imagine a product or system that could do this, like you could use it in conjunction with those other methods, and that might actually be the best effect. But the flow here is that you wear a device while you're sleeping. It collects the data and maps them to sleep stages. And then there's a detection sync that happens with your alarm clock, such that the alarm clock wakes you up at the end of REM or whenever you're most likely to remember your dreams. Since this system can update its ability to make that prediction. And then the system prompts the user to recall the dream upon waking. When the user records that content spoken to the system, there's then a measurement of the success of the system's ability to improve dream recall that's based on factors like frequency, length, detail, and response time of the dream reports. And so the design approach here that we want to keep in mind is that the app should really return how it's making its predictions to a user in non-technical language, saying something like, the system uses data from your sleep patterns to identify when you're in REM, and then that's when dreams are most likely to occur, and we wake you up at that time because you're more likely to remember your dreams. So along with that communicating level of certainty, we woke you up at this time because we're 70% chance that you're in REM, although I think with systems today you can get a lot better than that, but say 70% chance you're in REM and 50% chance you're going to remember your dreams. The more data it collects, the better it gets at detecting sleep stages and ultimately to predicting when the right time to wake you up for dream recall optimization is. And so this means that the experience is probably going to change over time, and this should be communicated to the user. And so the 6 principles of UX and the way they map to this product include visibility. So, the dream recall prompt needs to be made apparent to the user. Submission needs to be accessible. Sleep data should be visible. The dashboard should be user friendly, and the summary report should be available to the user. The user should be able to provide feedback, confirm and summarize after their dream reports, indicate that they're able to recall their dreams and experience the alarm that wakes them up to recall their dreams. Constraints we're working with: relatively simple yet intuitive UI. There's not too many interaction options, but the essential functions here are about alarm setting, dream recall response, and the success metrics of that recall. The mapping principle here corresponds to clear relationships between the controls. So when you're getting woken up, if there's other things that you're doing like setting intention or galantamine, those should probably be recorded as well. Alarm triggers that prompt dream recall and are tied to REM sleep. Likewise, kind of mapping input and experience output. Consistent design elements, seamless experience, unified brand, and then the affordance of, the design elements need to make it very clear how to navigate the application, submit dream reports, look at your data, etc. AI-specific considerations include transparency, communicating uncertainty, and feedback loops. So transparency in how the data is collected and used, an explanation in the user guide for that, and then really the model sharing, this is how we're optimizing dream recall time. This is what we believe the optimal dream recall time is. The uncertainty coming through in, we woke you up at this time, but these were some other times. Less confident, but these may have also been good candidates for waking up and improving dream recall. And then a feedback loop, the user gives feedback. There's explicit feedback opportunities for the user and then implicit. Privacy considerations for this application are really important since it's effectively healthcare data, right? Biometric data collected from sleeping users, and then psychological data as they're recording their dreams and journaling. And so unauthorized access or misuse would result in privacy violations for sure in a number of regional markets. Collecting and processing that data needs to be made clear to the user, and they need to opt in explicitly. Transparency about how the data and the dream journal data, the biometric data, how all of that's being stored and processed. And then there's inference possibilities from this, both healthcare related data and then psychological data is present in the dream journals. So care needs to be made in how that data is ultimately analyzed and what insights are drawn from that and how that's saved. And then if this data is ultimately shared with a third party for marketing or research, this could compromise user privacy and open up kind of extra legal ramifications. So there's applicable privacy laws here, GDPR in the EU, similarly CCPA in California, and then HIPAA at the federal level in the US. GDPR requires explicit consent and grants individual rights. Same to California, slightly different, but effectively the same type of law. And then HIPAA's healthcare data regulations mandated across the U.S. And as soon as this data is shared with providers and insurers, it effectively falls under HIPAA. And this could be the type of data that could be leveraged by doctors or insurers as complementary data, along with whatever other physiological, psychological data that the patient is getting covered for. Possible sources of bias here, there are 5 in the model pipeline, and so data collection bias, I think, is the main potential source of bias. So new tech's often picked up by younger, tech-savvy demographics, so this could skew performance, and you have to be careful about how the foundational model is trained by the data collected by the user base. But you can also introduce bias through feature definition and labeling. How dream recall is defined and measured impacts the outcome here, and then the way the model ultimately learns over time. And because users are self-reporting, there's a memory and reporting bias coming from the user that's going to come in the results. In the training and evaluation stages, dream recall prompt times are going to reflect the bias. Some groups may report dreams more frequently than others, which could skew the model's ability. Deployment, if someone is using the application but they actually have a sleep disorder, then this would be an example of an issue post-deployment that would be a type of bias that needs to be accounted for. And then there's feedback loop. So if a system is overtailing to a certain demographic of users that are responding and engaging and giving feedback a lot, it might overfit for that user group. Fairness and ethical considerations amount to the 3 principles of fairness, accountability, transparency. So it needs to perform equally well for all users with error rates that are basically equal for the demographics, and regular auditing to ensure that equality and function. Accountability, the designers and managers need to be clearly responsible through the product experience so that the end user knows who is accountable for this product, right, and its output. And mechanisms for feedback and addressing those issues need to be decided way ahead of the product's deployment with regular review of identified ethical risks. transparency and how the data is being collected, used, how the system is making its predictions, clear and accessible information about data usage and model function, interpretable models and explanations to help users understand the predictions. All of these things are, I think, crucial in a model like this that is inferring off of healthcare data. So in conclusion, human factors amounts to good product design that's done in an ethical and effective way through the design, engineering, and product development and operations process. And so ethical AI is those three principles. Again, fairness, accountability, transparency, how the model works and what that means conveyed to the user in as simple language as possible. Privacy, ensuring data is collected and stored in a compliant way. Private by design, this is an opportunity to use federated learning, I believe, so that the model is just learning from user behavior on device, and then it's not, data isn't taken and stored. And then well-being is really the highest priority of this product. The UX needs to be user-friendly, value-creating, and transparent about how the product works. And from a future point of view, we want to continue improving the product based on this feedback and advances in AI and sleep research. Thank you very much.